Assalamu alaikum. Welcome to lecture 3 of chapter 4, surfaces, tribology, dimensional, and so on. Before I start, I was not very well this week. My throat is still not back to normal, and something very strange happened. Last week I recorded all the different portions of lecture 3 almost till the end of the chapter, voiced over, making the video, uploading to YouTube, sending you the links. But now I find that the voice somehow has not been recorded. So this is really tough. So with my sore throat and so on, I am re-recording the lectures. Let us look at what we will cover today. Of course, very quickly we will review what we did in lecture 2 last time. We will continue with non-destructive testing, magnetic particle, ultrasonic, acoustic emission, acoustic impact, radiography, eddy current, thermal imaging, holography, destructive testing. So this is the largest part of the chapter. Then we will move on to quality assurance, where we will talk about frequency distribution, Six Sigma philosophy, control chart. So let us see, what we covered last. We were talking of electronic gauges, where rather than analog, the digital readout is already there. Measuring geometric features rather than actual measurements of length and so on, things like straightness, flatness, roundness, and profile. Optical comparator, gauges where we have master gauge, limit gauge, and inside limit gauge we have go no go gauges, snap gauges, ring gauges, plug gauge. Then each one of them in turn go no go gauges, snap gauge, ring gauge, plug gauge. Measurement of angles through protractor, bevel protractor, microscopes, especially tool makers microscope, and advanced technologies, where the first advanced technology is coordinate measuring machine, CMM, different versions of 3D, 2D, gear measurement, advantages of measurements with lasers, light beam with laser, scanning lasers, a general diagram of how laser measurement works. So that was that topic. Then dimensions and tolerances, very briefly, because you actually have done a lot of it in engineering. What are the factors, dimensions, and tolerances according to the ANSI, American National Standard? Bilateral tolerance, unilateral tolerance, limit dimensions, and a very good diagram of dimensional tolerancing with a shaft and a hole example, and so on. And then a very good diagram again about surface roughness and tolerances in different production manufacturing processes. After that, we started with testing and inspection. The previous one was a very short section. Introduction, measurement, inspection, testing, different techniques, manual testing, automated testing, sample, destructive testing, proof testing, non-destructive testing, and then the different techniques of non-destructive testing or non-destructive examination. I don't go through the list because it will be covered later. So then the first one, liquid penetration or liquid penetrant. This was where we stopped last time. We finished the first technique in non-destructive examination. So let us start now with the second technique. This is magnetic particle inspection. Magnetic particle inspection. If you see in A, B, and C, magnetic field is showing disruption by a surface crack. See, there is a magnetic field, but whenever there is a crack, it is disturbed. Whenever there is a crack, the field is disturbed. So magnetic particles are applied and preferentially attracted to the field leakage, and subsurface defects can also produce surface detectable disruptions. So in effect, what is the technique? That you coat the area with some very fine particles which can be magnetized. Then you put magnetic field around it. Normally all the magnetized particles will arrange along the magnetic fields, but wherever there is a crack or a flaw, they will show separately. So this is magnetic particle inspection, MPI. The principle: when a part is magnetized with a magnetic field, a defect on the surface causes the fine ferromagnetic particles, right, iron type particles which can be magnetized, to gather visibly around it, and the particles take the shape and size of the defect. Here is a hook, here is a gear type thing. So now see that you have done the thing, and now you can very clearly see the crack, right? You can very clearly see the crack. So magnetic particles have to be there, and you have to apply magnetism, and then you see the shape. So here I am taking some pictures from the industry. You can see that there is a plate which has been welded. You want to see the cracks. So this portable magnetizing system is there. So right on both the sides, so that north and south. Similarly here, there is a pipe connection that we are making. So this portable magnetizing system, one side here, one side there, and in between there will be iron filings and so on, right? So you have to distribute very fine powder of magnetic particles, and then you apply the magnetism, and then you see it. I have done it myself when I was in the field as a quality control inspector, both liquid penetrant and magnetic particle inspection. Ultrasonic. The name is very clear. Sonic means anything related to sound, and ultra means at a higher level, right? So the principle, high frequency sound waves. Sound waves sonic, high frequency sound waves ultrasonic. So high frequency sound waves are propagated or sent through the test specimen, and the transmitted or reflected signal is monitored and interpreted. You know, this is a very common thing in medical inspection also. Ultrasound and so on is there. So they send sound waves through your body, different parts of your body, whatever they are inspecting, and by the returned signal they can see the defects and so on. In ships, when ships are going, they want to find the depths of the sea, then sonar is there. Similar thing, they send sound waves down. When the sound waves reflect from the bottom of the sea, then they measure it, and so forth, right? So the same type of principle here. What is the advantage? Can reveal internal defects. This is big because the previous two, the paint type was only surface, the magnetic was surface and just below surface. This is internal defects. So you can, whatever defects are there which you cannot see, which are inside the surface, can also be seen. And it is highly sensitive to most cracks and flaws, and it is a high speed test with immediate results and so on. So go through the advantages. Limitations: difficult to use with complex shapes. You see, the shapes have to be relatively simple and flat and so on, right? So again, go through the limitations of the system. Material limitations. There are few materials that can be used on metals, plastic, ceramics, glass. So therefore, the limitations are very few. It can be used on most of the materials. Geometric limitations, again, just like earlier, a small, thin or complex shaped parts will have a problem. And the good thing is that a permanent record is there. With other type of inspections, you record with your hand. You say, I have seen this, I have seen this. Here, the record can be there permanently in a machine. So here we are just schematically showing you that this is the monitor computer type of thing, right? And from here you have this monitor, and here is your plate or your part with a crack. So then you will send sound waves. They will go, when they will hit a gap, they will come back and they will show you, right? So the reflected sound energy is displayed versus time, and the inspector can visualize a cross section. Now the thing is, I have used it with trained technicians, because this ultrasound type of thing is like a small computer, like a small handbag and so on, and you have to be specially trained to read it and to record it and so on. So this is another drawback, that every simple person cannot do it. The people who are especially trained can do it, but the great advantage is that internal defects which are inside the material anywhere can be easily tracked.